Hello everyone and welcome to the first tutorial or the first lab in the Reservoir simulation course. Today we will be discussing the data file, the Eclipse data file, and the different sections that you should expect to have in this data file. And then we will see how to run this through the Petrel platform and how to search for different keywords to understand what does this keyword mean and what are the expected inputs for each of these keywords. So the first thing we do is that we create a new folder. This is really important so that when you run the data file, you would know where to find the results and where to load the results. That's one thing. Another thing is that when the data file runs through the Eclipse, it creates subfolders. So just in order not to have everything in a hectic way, it's better to organize it in a different folders. And I'll call this lab 1. The data file we'll be using today is SPE case 1, and I'll get this from going to PC and then go to the C drive, go to ECL, which is an abbreviation for Eclipse 2017, and then Eclipse data. You'll find a lot of data files. I want SPE ODA impus. This is the data file that we will be using. I'll copy this to my newly created folder. Sometimes you won't be able to open it because the default for the data file extension was not defined on your PC. So you will just right click, open with, and choose the notepad. This should open your data file. The data file, as we discussed before, have 5 main sections and 3 optional sections. In order to run the data file correctly, you must have the 5 main or required section with their main inputs. The first one is the run spec. You find the title of the simulation run. And then the dimension, which is the number of grid blocks in X, Y, Z direction. These are in Cartesian coordinates. In case this is the radial coordinates, we will see later that you will have another keyword called radial, which indicates that the dimension will be in radial coordinates. And then you will have R, theta, and Z instead of X, Y, Z. Then the phases, definition of the phases: oil, water, gas, and dissolved gas. The definition of the units, this will be using feed units. And then the starting date for the simulation run. These are the main inputs in the first section, the run spec section. The second section is the grid section, where you define mainly the grid properties and input the rock properties into each grid block. So what you will have here is the dimension in X, delta X, the length of each grid block in the X-axis, the length of each grid block in the Y-axis, the porosity. This is a simplistic model, an ideal model. So all the grid blocks have the same delta X, delta Y, and porosity. For the delta Z, the thickness of each grid block, we have 3 layers, each of a different thickness. The first layer have a thickness of 20. This applies for grid block 1 to 10 in the X direction, 1 to 10 in the Y direction. So basically all the grid blocks in the plane XY, and the layer 1 to 1 only. So the first layer only would have a thickness of 20 and permeability in the X direction of 500 millidarcy. And the tops for the top layer, you need to define tops for the top layer only, and then you can just add with the delta Z to get the tops of the second and third layer. This is the definition of delta Z for the second layer, so it would be 30 and 30 feet. And I know feet because in the run spec section, we used field units. So 1 to 10 in the X direction, 1 to 10 in the Y direction. Again, all the grid blocks in the plane, and the Z direction 2 to 2. So only 1 layer, and delta Z, same thing. So I define the porosity, I defined the absolute permeability. This perm X is the absolute permeability in the X direction. And then we would just copy the perm X to perm Y and perm X to perm Z in all the 3 layers, all the grid blocks, basically 1 to 10, 1 to 10, 1 to 3. So this is pretty idealistic, but you get what we want to do here. So in the grid section, you would input the grid properties and the basic properties, which are the porosity and the absolute permeability. The third section would be the props section, where you define the fluid and rock fluid properties. So you will have the saturation of water versus the relative permeability to water and the capillary pressure between oil and water. You have the saturation of gas, relative permeability of gas, and capillary pressure between oil and gas. You will have the same we will have the saturation of oil versus the relative permeability oil water and relative permeability to oil gas. And then we have the water properties at reference pressure, the formation volume factor, the compressibility, the viscosity. The rock properties we'll have at the reference pressure, the value for the rock compressibility, the density of the three surface oil, surface water, and surface gas. So these are at surface conditions. And then you would have the table for the properties versus the pressure. So the pressure of gas, and then the beta and the viscosity. You would have the pressure of oil, formation volume factor, viscosity, and oil solution gas oil ratio. So this is basically what we have in the props section, the fluid properties and the rock fluid properties. And the relative, so we have the absolute permeability in the grid section, and we have the relative permeability in the props section. The third required section is the solution section, which help us initialize the model. And what we need to define here is the datum depth and the pressure at the datum depth, and then the depth of the contacts, the oil water contact and the gas oil contact. And then you can also define the depth versus the solution gas oil ratio. I'll skip the summary section for now because this is one of the optional section, and I will go to the last required section, which is the schedule section. And in the schedule section, we define the wells, the well locations, and connections and constraints, production or injection constraints. So the first keyword is the well spec, where I define the well name, I define the group that the well belongs to, the I and J location, X and Y, and the bottom hole pressure depth and the phase, if it's an oil, gas, or whatever. In this model, we have two wells, an injector and the producer. The second thing that I need to define is the completion. So I place the well, I need to perforate the well in some of the grid blocks. So I will define here the completion data for the well name, producer, the location in I and J, and then how many grids in the Z direction were perforated. So here they perforated the well in the lowest layer only, the layer 3, and for the injector in the top layer only, layer number 1. The third keyword is the WCon prod, which are the controls for the production. The well name, producer, its status is open, and I will control it with the oil rate. I need the oil rate to be constant at 20,000 stock tank barrel per day. All these 4 other constraints are left constant. And then I define the bottom hole pressure threshold as 1,000 psi. So this means the model would keep producing at 20,000 stock tank barrel per day as long as the bottom hole pressure is higher than 1,000 psi. The moment the bottom hole pressure reaches 1,000 psi, the control mode will be shifted to the bottom hole pressure. It will be constant at 1,000, and then the oil rate will be the one that varies. Because I have an injector, so I will have the WCon eng, the control for the injector, and we're injecting gas in this well. It's an open well, and I'm controlling with the injection rate, and it's 100,000 MCF per day. So these are the 5 main sections that I must have in order to run this through Eclipse. The 3 optional ones are the summary, region, and edit. We will often use the summary section because it defines specific outputs that you need from your simulation run. So if you don't have a summary section, you will just get the production rates and the pressures. But in the summary section, you can define either specific specific field result, specific well result, or specific group or block result. So here we have the field oil production rate specified, the field oil production rate. For the wells, we need the well gas oil ratio for the producer and well bottom hole pressure for the producer. And for specific grid blocks, we need the gas saturation at block 10, 10, 3, and 111. These are the where the producer well is perforated, and this is where the injector well is perforated. We also want the oil saturation for both grid blocks and the pressure and block pressure for both grid blocks. The other two sections that we don't have here is the region, where you can define a different region, like dissect your reservoir simulation into compartments that you can see the results separately. And the last one is edit, where you can introduce changes to the calculated pour volume and stuff like that. But we will not use these in our undergraduate level. We will just focus on the 5 main sections added with the summary section. So this is the quick overview for the data file. We want now to learn how to run this through Trell. So I will open the Trell package. It will take just a moment. Then I will not change anything in this window. This is the license window. I'll just click on OK. And this should launch the interface of Petrel. Here you go. As you can see, I cannot really do anything. Everything is shaded here. If I go to the simulation tab, you'll find that you have nothing at all. But just by clicking File, New Project, this will allow you to go to the simulation. It also should take a moment. And then when the new project is loaded, we will go to Legacy. We'll find an icon here called Legacy. Here you go. And we'll open Eclipse. So this is the window that I'll be using to run my simulation. I'll click on File, New Project, and go to the created folder. I created it in the desktop, Lab 1. It doesn't see anything because I did not define the data. I only have a data file. So I should change this to data and then select my data file. I'll get this window asking me which type of simulation I want to run, and for our undergraduate purposes, and 90% of the work you will do in engineering, you will just need Eclipse, which is the black oil simulation. So you see that we can click on Run, Go, and just click Yes on this, and we should get the black window that tells me what's going on with the simulation. So the simulation is currently running. And at the end, it should tell me the number of errors or problems. The status here is finished. So this means the simulator did not encounter any issues or errors. There are some warnings though, the ones shaded in yellow, but as long as we don't have anything shaded in red, this means the simulation went fine and we should be able to see the results. I will close these windows and go to results. And then I will open the data file, the current case. I will load the summary and read all summary vectors and click on load. And then here you can see B stands for block. So here we should have the gas saturation for block 111, the gas saturation for 10.10.3. These are the ones that we added in the summary section, the oil saturation and the block pressure. These are the 6 outputs that we asked the simulation to output for us from the block section. The field ones, you'll have a lot of field properties here. Let's just plot the field pressure just to have a feeling of what happened. So FPR, field pressure. As we can see, the field pressure is increasing, and then by the 800th day it starts decreasing. So this is an indication for the gas breakthrough. Anyway, the G stands, if you remember, we had all the wells in group G, so this stands for group that we name G. This will lump all results of the 2 wells. And then the last one is W, which stands for the wells. We'll have the well bottom hole pressure for the injector, well bottom hole pressure for the producer, and so on and so forth. So that's how you can visualize the results. You can also add 2 charts or 2 lines to the same chart by just right clicking on whatever input you want to see, output, sorry, you want to see, and add graph. Then you have the bottom hole pressure of the injector in green and the bottom hole pressure of the producer in red. This is how you can see the outputs, the charts of the outputs. We can also have a visualization for the system from legacy. I'm getting back to Petrel. I'm going to legacy, flow viz, which is flow visualization. And I will click on file, open, Eclipse, and I will load the one.fgrid and click on OK. And this should give us our model 10 by 10 by 3. I'll just zoom in a little bit on the z-axis. As you can see, 10 by 10 by 3 layers. Each of the grid block is a perfect square in the XY plane, but the delta Z is different for each layer. We saw that in the grid section in the data file. The color coding is for the oil saturation. So the lighter color has lower oil saturation, and the darker red is higher in oil saturation. And we can play the simulation. You see the date is changing here, and of course the saturations are changing because you're injecting gas from this well and producing oil from this well. So this is how we can visualize our results through flow visualization. The last thing is how to get the keywords, to understand the keywords. So again, I'll go to PC and go to drive C, ECL 2017. But instead of going to Eclipse, I will go to manuals and open the bookshelf. Make sure you right click and open this in PDF to allow you to navigate between the technical manual and the reference manual. The reference manual will describe the keywords, and if you go to any of the keywords, I'll go to the WCon prod, for example. I'll search for it. So this would tell me which type of simulation this keyword should be used for, and this one can be used for Eclipse 100, the black hole simulation, or Eclipse 300, the compositional simulation. And this keyword should be written in the schedule section, and that's what we actually saw in the data file. And this keyword should be followed by a number of records, which are the well name, the status of the well, open, stop, or shut, and then the control mode. If you remember, we controlled with O rate, oil rate, and then the value for the oil rate, for the water rate, for you can see the units of each of these rates in the field or the metric system. And then the last one should be the gas rate, the water rate, the gas rate, the liquid rate, and the last one should be the bottom hole pressure. So these are the 9 inputs that you should define after using this keyword. So this is how you can search for any of the keywords, understand what does it do, and understand what are the inputs that you should enter after using this keyword. Also, if you're curious about any of the calculations, you can go, I went back to the bookshelf and then I selected the technical description. And here you would find the equations that the simulator used to calculate or compute all the different calculations. You can go to any of these and see the equations and how so here's the mixed water permeability, for example, and here's the equation that it's used, and define each of the parameters and define the methodology of the calculation and so on and so forth. So this is just for your own curiosity. If you're curious about anything, you can go to the technical description and understand what's going on. The one that we will be using frequently is the reference manual, when I will just ask you to add something and you would go search for the keywords that would help you add this. And it should be useful for you to understand any keyword that you don't understand in the data file. And I think that's it for the first session. Thanks, everyone.